Hey, so what we're going to be doing today is finishing off that question about the bacterial growth that we did before using logarithms instead of using our graph to find the intersection of when the weight reaches a certain amount. So you can see that how we did that before in my link below. So let's say we had this weight time of bacteria growth and we wanted to find when the weight of the bacteria was, say, 1,000 or 5,000 grams. So what we're going to do first is just put in our value of 1,000 into that equation. 1,000 equals 100 times 1.07 to the power of t. So first, let's just simplify it. We can divide by 100. Luckily, I picked these easy numbers, so I didn't have to deal with anything complicated. So dividing by both sides by 100, we can get rid of a bunch of zeros here. And we get our final 10 equals 1.07 to the power of t. So now, what are we going to do next? Let's just take log of both sides. If you know how to switch around log quickly, you can do it any other way you want. I find this is the easiest way to not screw it up, is just to take, that's an ugly O, take the same log of both sides. How do I know what base I want in the log? It's the base of the exponential above. So log of 1.07 to the t. Looking at the left side, we can't simplify that. We'll just put that in our calculator later. The right side, however, we have, it's just t, right? Because this t exponential, it comes out to the front by our log rules, and log 1.07 of 1.07, that's just 1. And we get our final value for t is log of 1.07 to the 10. I'm going to put that in my calculator later because I don't have it out. So let's just also quickly simplify for what it'll be when it's 5,000. So 5,000 equals 100 times 1.07 to the t. And similarly, let's just get rid of a couple of these zeros and put it into the log equation like we did before. Skipping some steps. T equals log 1.07 of 50. And now let's get out that calculator to find these values. How do I open my calculator? There it is. So we click on math, and up there A is log base. So we're going to want a log base of 1.07. and put in our value 10 here. And you get 34.0. And let's just fail at copying this. Okay. Down, 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 down. Nope. Yep, nope. Okay, there it is. Log 1.07 of 50. And we get 57.8. So putting those numbers back in, we get that t equals 34.0 and t equals 57.8. And then we go back to looking at the question and think, what do we need for the units for t? Let's just say seconds because I forget. And I don't have the question in front of me. So there you go, solving an equation using logarithms.